Hello friends, welcome to FoxuTech. So, you're all good. So today we're gonna see about Kubernetes resource request and limits. So if you are following our FoxuTech.com like a blogs, so you may read about this like in our last post. We have explained about evicted state of pods and how we have to kill it. So one of the key reasons for the evicted state is like it may be running out of resources. So that is one of the major reason the pods get down or it get stopped unexpectedly, right? So to avoid those things, what we have to do, like in this post, we can see about like what we can do and how we can fix it. So also this is recommended from the Kubernetes aspects, best practices. We should always enable these requests and the limits, and this will have a lot of advantages. And also if you are preparing for any kind of Kubernetes certification, this will be one of the question how we have to limit this resource or request. Please just check about this, and we'll try to explain you better for help you to understand how it's defined and what it helps, right? So yeah, let's start. So before we head into this, like what we have to do, so first we have to understand how the Kubernetes deploys the applications or the pods to the nodes, right? And how it will be there, share the resources. So there is a lot of resources are required. So when you speak about the resources, it can be a CPUs, or it can be a memory, or it can be even network. And networking has a lot of resources, and like that, there is a lot of interdependent resources. But this post will be mostly focused on the two things. One is CPUs and one is memory, right? So to understand that, what we have to understand how the Kubernetes is deployed, right? So Kubernetes is nothing but if you have a physical VM or the virtual VM, so it will has a defined or fixed number of CPUs, fixed number of memory, right? So in that, what it does, so on top of that, whenever you are putting any kind of application, and that will be try to consume the same number of CPUs or same number of memories. So it cannot be accessed beyond that, because the node doesn't have a capability to provide you the more number of resources, right? So it always should be defined within the limit what the node has. So if you are using any kind of a cloud with some auto scaling option, you may not bother about this option. Why? Because sometimes what the cloud provider does, it automatically enables some auto scaler, so that will enable the number of nodes on on-demand basis, and it will take care of the reducing the number of nodes based on if there is no any consumption, right? So this will be like a more focused how it will be defined, but we are not focusing on the auto scaling part, but rather we try to explain you how you can well plan your pod resources, right? So this is how the whole cluster will look like, and you will have multiple nodes. In this case, I have 3 nodes. Your case will be completely different, and each node will have a certain apps. So if you are deploying any apps, it will be automatically deployed based on the number of based on the availability of the node and also the availability of the resources. So what happens when you do some, let's take like you are running a kubectl apply and pod.yaml. You have defined your pod.yaml, and whenever you are deploying, so immediately the Kubernetes scheduler will pick that and see which node has enough resource, and it's try to understand which node is available first, and then it's check the resource availability and what is the resource defined on the pod. So if the node is the pod is not expecting any kind of resources or something, it automatically check each node, like it's check the current consumption of the CPUs, and it will be allocating the pod to the particular node. So what happens if there is no response received from the nodes, right? So even though you may get failed, so please be noted. So you can retry it. So what happens sometimes if there is any network issue or something, that may not be particular node not respond to the kube scheduler, and that will be failed. But it rarely happens in case, right? That's one of the scenario you should know about it. In that case, you can reapply it, or you have to wait the Kubernetes scheduler will wait until the node responds, and then it's help you to deploy to the particular node. So that is one of the failure scenario may happen, but please keep in that mind. Otherwise, it will be pick any one of the node based on the round robin algorithm. So if the round robin, as you know, it's Kubernetes is works on the round robin algorithm and it picks the nodes. So one time if it's put the node 1, next time it will goes to node 2, and next node 3, again node 1. So one by one it goes, right? So like that you can see, but here we have defined 1, 2, 3 as a very proper manner, but it's not always happens, right? Sometimes if the node 1 is already consumed with the more resources or with the more consumption of any other resources in the system level, so if the node app 2 has to be supposed to be deployed, it will be deployed any other nodes wherever there is enough resource. So that is how the Kubernetes works here. And so next is like a pods. So pods are nothing but, so it's a combination of, it's a more number of like a containers, more than one container can be deployed on the pods. There is a possibilities, but it's not recommended always. The best recommendation is you should keep single container inside the pod, right? Some unavoidable situation you can use it, but please plan your resources accordingly. So what happens, like let's say like you have a pod and you have defined to use only certain number of resources, but there is another pod, the new container, whatever you added, unfortunately it's expecting a more number of resources. What happens? Immediately it's even the both the containers may have high chance to fail, but it won't happen. The highly consumption only fail, but in case, right? So your Kubernetes treats as a single pod only, it won't consider as a single containers always. So it will be like a try to kill you the pods level. So always be sure on the pod level, whatever you are defining, it will be proper and you are controlling it properly, right? Well, so let's see that now. Let's speak about the request and limits and how it will be help some case like your pod is getting overkilled or the like it's not consumes excess amount of unnecessary memories or unnecessary CPUs, right? So request and limits help you on that aspects. So requests are nothing but like what is the minimum amount of resource I need to run this container, right? I need to define. So what is the basic CPUs needed, basic memory is needed first. On top of that also, I'm going to define what is the limit I have to set. There should be a boundary for that. So see, whenever you are starting, you can use this much memories and this much CPUs. And on top of that, you cannot use more than this limit, right? This should be always set. So why this? Because this helps you to avoid the particular container to consume unnecessary memories or unnecessary CPUs unexpectedly, and also this will help us to equal the number of resources used on the other pods will be running on the different applications or something, right? So always there will be a more than one pods will be running on same nodes, so we should have a space for that to be given, so they will be consuming a number of resources. So well, so we have seen about like what is this. I hope this helps you to understand. So next, say like how we have to define it, right? So how we can define what is the value unit of the CPUs and what value unit of memory, right? So CPUs will be like a cores or CPUs. It will be differs based on the environment where you are using. And here one core, like by default all the CPUs will be called like a one core, and in Kubernetes we have like a 1000 M. So M is defines like a milli CPUs, sorry for the typo, milli core, right? So it will be called as milli CPU or milli core. So we will be calling as a milli core in this tutorial. So let's please be noted. And if you are using Azure, so if you are using a one core, it will be called as a one Azure V core. And if you are using AWS, it will be like a one V CPUs. If you are using a GCP, it will be called as a core only. But if you are using an Intel processor, it will be like a one hyper thread. So it defines every environment, please define accordingly. And whenever you are checking available resources on the node, please read as per this term, and please be plan your parts request and limits. And even that's not like a mandatorily you should give a full number of resources, like a CPU should not be always high number, full number 1 2 3 like that. This give a privilege to limit like a one third of CPUs, 1/2 of CPUs, 1/4 of CPUs. You can give, let's say, like if you want to use op CPUs. So if you want to use op CPUs, you can give 0.5 CPUs, or if you are using in the numbers like a 500M, you can use. Or if you want to use like a 1/4, right, quarter. So that will be like a 0.25 CPUs and 250M, so milli-core of CPUs. Okay, so this is a unit for the CPUs, and when it's coming memory, so memory is depends on the bytes, and this can be a tricky part because it can be defined on the multiple terms, SI units or SI values or SI power of 2 units or power of 2 values. So mostly used SI units and power of 2 units based on your football option. You can define it. It can be a kilobyte or megabytes or gigabytes or terabytes, picobytes or ecobytes. So it doesn't matter like how many bytes you are defining. So nothing, but you have to see first what is your node is having a capability. If your node is having a 3 megabytes or 300 megabytes or 3000 megabytes or gigabytes or petabytes, whatever the numbers it has, please use accordingly and put your numbers. Okay, and same for the power of you too, like it's like a millisecond, so everything like a megabytes, kilobytes, terabytes, you can use it. Or if you want to use the power of 2 CPUs, sorry, power of 2 values, it will be like it differs. Whenever you say like a 10 power 3 will be like 1,000, but when you say like a 2 power 10 is like a 1024. So there will be a little change. So always go with the full numbers, or if you know about how to calculate the memories, it will be like a 1 GB equal to 1024 megabytes. So you can calculate accordingly and give the required resource values. So next is like how the request resource will be calculated, right? So let's consider you have a node with the 8 CPU core and 12 GB of RAM, and that will be like a overall nodes resource. And it's not like there is a node with the 8 CPU core and 12 GB RAM. I can't use all the nodes with the complete resources. So there is a trick part we have. There will be a certain amounts of resource will be reserved for the certain applications. In our case, system may need some like some of the basic resources. Any operating system, obviously, it has some reserved operations. So for that, it needs some certain CPUs or certain memories or combine both. So it will be consumes that. And when we are running a Kubernetes, again, the kube reserves some certain kubectl reserves some of the CPUs, and also the kubelet runtime will be reserved some of the memories. Okay, so this will be defined here, and once we minus that values from the total number of CPUs or sort of memories, and the remaining will be counted as a absolute capability, right? So with this only we have to plan our capabilities always. We should not overcommitted with the overconfident with the complete numbers, right? So please keep that in the, please be noted on that aspects, because that is the one key thing we may miss when we are calculating, and that may give us a lot of issues. We may end up with the big issues when there is a over commitments of the issues happen. The parts are getting killed for unnecessarily, there is no proper planning is done, right? So next is like a request. So whenever you're seeing like a already, if you're going with the proper limit, if you know what is your absolute capacities, and when you are planning for the request, so that obviously give you the well clear idea about how much part request CPU resource I should request, and the memory resource I should request. Each parts whatever I'm creating, I know about well-defined numbers, and also always I'll be planning very tight and I'll make sure there is some leftover. Why? Because some case like if you're running some application that's certainly looking for some additional memories or additional CPUs. So with the certain values, the leftover, what we can do quickly, we can switch that. We can quickly update that, and that will help us to serve to the more number of like users, or some like a more number of requests can be processed to the other applications. So always the leftover is preferable, and we should have it. So in case if you are not identifying any kind of resource, so what you have to do, so you have to increase your number of free cores, total cores, and you have to make sure that is all given here, right? So in case you are not fitting, unable to fit, try to move to the another node. In case you want to keep everything on the same node, please plan to upgrade your base node CPUs or the memory or whatever it's not suits. So you have to plan for increasing that. And also again, you calculate certain numbers. Always give some enough numbers here, because that may give us best performance. Some case it may fails lot or fails quick. So this may be one of the key reasons that even the complete system may go slow. So always give some numbers to the systems and the cubes always, right? So this is like a well-planned one. So in this we can say like the parts are being guaranteed, so it won't be go down anytime. So over commitment is not possible, because we do have a proper leftovers, so it won't be a problem for us. And values used to pod scheduling properly in this. So there will be any X, we have to see that. But let's see that limits when we say, so you have to plan accordingly, like what is the commitment you are making, right? So in case you are not well planned, what happens? So your CPU, if you are hand with the CPUs, there will be some throttles you can make it. So it will be help you to adjust it, right? So but when you say like a memories are obviously it cannot throttle. So it will be non-throttled one, so it will be fail immediately. So that's what you may see when, if you have a experience, you may seen about the application runs out of memory, or it may end up with some like memory is insufficient. So those kind of errors may arise. First, CPU will be the last resort. Sometimes it may not give immediate values, but it may be one of the key reasons to degrade your performance application. Right. So over commitment, we should not keep it always. So well planning is mandatory for any kind of resource, not only for the Kubernetes I'm speaking here, any kind of application you are working. So please be planned for your application and understand about your application first. What is my application? How many requests it's have to handle, and how many CPU it may consume if there is this number of requests. And if there is what happens if there is a sudden ratio of 2x or 5x range of requests are coming, so how my application will be handle those kind of requests. So pre-plan for that, well prepare before, so that will help us to avoid any kind of situations like a application goes down or unresponsive or slow issues and so some application we may not give such a harder numbers, but when most of the application it's give us some best numbers always, and we can plan it upfront. So how we can track it. So either if you know application, you can do that, or over the time if you are running application, you can enable some application performance monitoring tools, and that may help you to give some insights about that. So we'll see that in the demo, like how we are running our pods and how we are doing in the pod aspects. But if you are thinking about your application, please check some APM tools like application performance tools, and that should help you to give some best numbers and will help you to plan your systems so application well before, right? So well planned, it will be help you to do that. Right. So hope this is clear. So let's see about demo. Like in this demo, we'll see like let's create some sample manifest file with the resource request and the limits, and we'll try to run that and see that is it how it's defining. And also we'll try to give some high number of CPUs and see what happens. Right. So for that, let's log into our terminal. So in the terminal, we'll see, we will be checking, like I have already have a pod here, pod file I have created. So let's say like I have pod.yaml. So this should have a value. So you can see I'm creating a pod and I'm naming my app name as alpha app. And I'm using again the Nginx image. I'm naming as alpha app. And I given the memory is 512M and the CPU is 500. But let's not give like high number. I'm gonna say like a 200M and I'm gonna limit the CPU's maximum limit is 500. So let me explain what I'm doing here first. So I'm doing a resource of memory should be 512 MB for this application. So it can be used directly and CPU should be 200 MB. And even I can reduce the memories as I don't want, as it's Nginx, I'm going to say like a 256 MB megabytes of memory it's going to use, and maximum what it can do, it can go still 512 megabytes, and the CPU can reach still 500 millicore, right? So beyond that, it's not allowed. So this will help me to make sure my node is not over consumed by any of the application. So now let me save it. And before we are running this, what we have to do, so let's check about our nodes first. So let's see, we have 3 nodes, right? And let's describe one of the node and see what is the current consumption and is there any pod is running. So I'm gonna say like a kubectl node and describing the first one first. Describe it. So here you can see we are not running any pods at this moment, and you can see it's a by default namespaces, and you have to come down and you can see this and what is the name of the pod, you can see it here. What is the CPU request currently and what is the CPU limit and memory request, memory limit, and how long it's running. Every details we can see it here, and allotted resource. So overall, this is the number. This is for the overall count, and this is for individual pods. All right. So we have seen about this, and let's try to apply our pod. So kubectl apply -f pod.yaml. So our pod is created. Let's see kubectl get pods. It's getting created. So let's wait to complete it. Okay, so we can see our pod is running, right? And so we can see like a kubectl get, sorry, describe PO. We have created alpha application. I'm giving alpha app, and we can see the limits are set. Right, so this is a request and this is a limits what we set, right? So now it's well and good. So we are seeing and how to track like how many CPU, how much the memory is using, right? So what you can do, you can use a kubectl top pod. You can see what is the pod consumption, how many CPUs are using and how much memory is using. Same you can do for the nodes. You can type node fully or you can use NO for it as a short form. I'm using a short form here. And you can say like how many P-core is used and how many CPUs are using, how many memories are using, how many percentage, right? So this may say like you can see, okay, my application is, my cluster is underutilized at this moment. So if you say there is high number of values, like which is more than 80%, values, so you should check your node immediately and take some actions. Why? Because that may, anytime it may reach, it may not reach, but always good to check why there is a consumption. Is it accepted or non-expected? If it's expected, you have to keep a eye on that and make sure that it's not overflowing, and that will be a best practice. So this you can achieve it with some kind of a monitoring tools, regular monitor. You can't run the command always, right? So we can make use of something like a Prometheus, or with the Prometheus and the front end, you can visualize in the Grafana, or even with the influx as a backend and a front end as Grafana, or any kind of a time-based series or any monitoring tool probably you are using. So you can use that, and that will give you the best numbers for you, and that will help you to make sure your application is always up and running. All right, so we have seen the pod consumption. Our pod is not consuming any numbers, and let's now describe it. So before we are doing so, let's check this where this pod is running, right? So to get that, get pod. So to say which node is here, provide, and this will say which node it's running. So this is running on this node. Let me describe this. Describe node. So this will be explaining you, and you can see it here. The default is a namespace what we created, and our name application name is alpha app. So this is a request, and this is a limit, and this is currently being used, but it's standard used at this moment. You can see whatever it's set, right? So let's see, like we have. This is a way you can track your nodes consumption. And also we can see we are not overlapping here. So limits will be higher number as I'm using Azure. So you may see this number always high. Please keep eye on the request, right? And so we seen about how to set that. So this is a value you can set for any pods or something. So this is how you can define it. You have to define the request resources, and under that, how much request it should be and how much is the maximum limit. You can define as per your need. So let's say like one more application, let's create. So I'm going to create like a pod.yaml, and I'm going to say like a beta app. I think I have delta app.yaml. So I'm going to say delta app. So in the delta app, I'm going to just rename the alpha to delta. I'm not going to change the base image. Let's be like Nginx, and what I'm going to do here. So I will show you what happens when you are over committing the request, right? So I'm going to request for that 3 GB RAM, or let's say like a 4 GB RAM. So it will be like a 4096 megabytes. And I'm again going to give the CPU is like something like a 1000 CPUs, and the limit I'm gonna set 5 GB, right? So let's say like a 5 GB, 5192. Let's example I'm putting 1500 MB. So this delta app, it's required like in the high numbers, and in that case, what happens? The Kubernetes won't take your application to be running state. It will be kept on pending state. We'll see how we can track that. So if you are over committed the request, so it will show like this. It's applied, but when you say your pods, it will be kept on the pending state. Even the beta app earlier I kept in the same state. So now it's delta app also. Let's describe this and we'll see what it's showing, right? kubectl describe pod delta app. So it's in the pending state still. So pending state still. So we don't have any reason defined here. So it could be there will be a event section. So it's not showing here. But how we can track this, right? So what you can do like a kubectl get events and see what is happening. So let's say like the pod is failed to schedule. Why? Because there is insufficient CPU and insufficient memory. And even the beta app earlier I was trying to schedule, but even that is having insufficient CPUs. So with this, your application won't be start until your number of resources increased to certain numbers. Okay. So yeah, this is what happens. And what happens if there is a certainly your application is consuming more number of memories or more number of CPUs, immediately your pod gets vacated. So it will be on the vacated state long. So you can track it using kubectl pod. And when you say describe, and it will show you the reason like why it's happened, or you can come to the events and see that. So even though if you say like, if you want to quickly check what is my pod consumption, you can run the pod top command and see what is my consumptions. Okay. So yeah, so hope this helps you guys. So this is how you need to define it, and you can increase the number, change the number, put a proper values, and you can have a resource and remits very well planned. So hope this helpful for you. So please be practice regularly and put some certain different numbers. So try for yourself. Hope this helpful, guys. So thanks for your time and have a great day ahead, and keep learning. And if you like this video, please share with your friends and like, subscribe, or everything. So we do always regularly post some tricks or tips on our social medias like Instagram. So you can follow us even on the Instagram, and you can just learn something in the short notes. So there we put like a very short notes, like explanation and detail, but that may give you some hints what is that, and also it may be related to you. So please make use of it. Thank you for your time. Have a great learning. Keep learning. Cheers. Bye bye.